So if we're given the opposite sides of the quadrilateral are parallel, we would mark them. And then we're trying to prove that they're equal. What's your first step, Quinn?
Well, isn't it like 2/3 of that?
Okay, so you could, so just thinking through the proof, if I numbered these, let's say I numbered them. When you were marking your drawing, what would you mark equal?
3 and 4.
No. Let's try again.
Oh, angles 4 and 1.
Angles 4 and 1 would be congruent,
And angles 2 and 3.
and angles 2 and 3 would be congruent. Okay, so Luke, what else would I need to show congruent triangles?
So you have two angles, so then you'd need another side. You can decide to be congruent, and you have the same side, CA.
Right. Good job. Okay. So if I have congruent triangles, Paxton, how is that going to help me? If I have congruent triangles, how's that going to help me?
Because you know that they're the same triangles.
Thank you. Say that a little bit louder.
Corresponding parts
Of
of congruent triangles are congruent.
are congruent. So here's the things that you guys have to pay attention to. If I wrote down BC is parallel to AD, what's the logical result from that? No, not the reason for that. What is the logical result for that? It is given, but what results from BC being Cal?
Alternate interior angles.
Which ones?
The angle
1 and 4.
It's because of the transfer.
All of them?
Only 1 and 4.
Only 1 and 4. Remember, trace over. Here's BC. Here's the transversal you're talking about, Cal. And here's AD. What angles did I just kind of capture? 1 and 4. So the only thing I can say from this is that angle 1 is congruent to angle 4. But from the other pair of parallel lines, AB
It'd be 2 and 3.
parallel to CD, that gives me 3 and 2. Do you see that? Like now, I'm looking at 3 and 2 being congruent. So I could say angle 3 is congruent to angle 2. So this is like a 2-column style proof. So the reason for this is what? Like if this were my step 1, what's the reason for my step 2? They're alternate interior angles, so you look at the step before and you see where it came from. So where did they come from? Yeah, and you guys state the conjecture in English. You write it out. You write a normal sentence out. So the normal sentence would be, if 2 lines are parallel, then the alternate interior angles, right. Does that make sense? Then I can do Luke's same segment. AC is congruent to AC. Okay, and the reason is because it's the same segment property. So the triangles are congruent. So what triangle, Sean? ABC to what? Okay, how about the other Sean? ABC to... How about Cal? ABC to,
C.
thank you. Because they have to correspond, right? This angle is equal to this angle. So A corresponds to C. B and D correspond. And then A. Okay, now I could say the parts are congruent. So BC is congruent to AD, and AB is congruent to CD. And until you guys convince me that you know what that means, you have to write it out. What does it mean, Michael? What's the reason? Starts with a C. What does it mean? Say it in English.
Congruent. No,
Help 'em, Mark.
corresponding parts. Corresponding parts of congruent triangle. Triangles. What's are congruent?
Or what is this symbol?
Congruent.
Congruent.
Yeah.
They're congruent.
I always get in trouble with glasses.
Okay, so that doesn't answer all your questions, but now I'm going to talk specifically to the kids. If you were trying to prove something was parallel, like you are on number 1, then I'm going to just draw a picture of that. I'm not going to do the proof. But there was a picture like this, right? And it gave you midpoints. And so you use vertical angles, and I don't remember the letters. Okay, but if you did a proof and you got to triangle ABC congruent to triangle DEC, so Miranda and a few of you, this is where you guys are, and you want to prove AB's parallel to DE, you have to go in the reverse order. Now to say you have parallel lines, you first need to have congruent triangles and then congruent. What would make this line parallel to this line?
Alternate.
You need to have congruent alternate interior angles. So can I say angle B is congruent to angle E?
Yes, because of CPCTC.
And what does that mean, Michael?
Corresponding parts. Corresponding.
Morgan, what's it mean?
Corresponding parts of a congruent triangle are congruent.
Corresponding parts of congruent triangles. Corresponding parts of congruent triangles are congruent. If you can't say that, you're going to lose points on a test.
So corresponding parts of congruent triangles are congruent.
Yes. Okay. Now can I say the lines are parallel? Look up, guys, because this is where people lose points on tests.
Wait, what did you have to say?
Can I say BA is parallel to DE now?
Yes.
Why?
Because all the alternate B and E are congruent are all B and E are congruent alternate interior angles.
Yes. And so you say the same thing, but you say it in the converse order. You take this and you reverse the order because the order is reversed in your proof. So now what came first, the angles or the lines?
Angles.
The angles, right? So you say congruent, or you could say if the alternate interior angles are congruent, then the lines are, write an if-then statement. If the alternate interior angles are congruent, then what's true?
And then lines B, A, and B are
Which we've said over here, right? So we just say the lines are parallel. So look at the difference in the two problems. Here we're trying to prove, if we were trying to prove, and I know I skipped the beginning of the proof, but AB is parallel to DE, then we have to show that the the alternate interior angles are congruent. So that comes first. Since the alternate interior angles are congruent, then the lines are parallel. You see, Miranda, what you were, and Sabrina? So over here, we were trying to show that the triangles were congruent, and we were given the parallel lines first. So then we write what we're given first. If the lines are parallel, then the alternate interior angles are congruent. Order matters. If you mess up the order, you lose the points.
Wait, it's corresponding triangles, corresponding parts
Are you?
are congruent if triangles are.
Are you?
I'm trying to.
I'm gonna stop.